Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Maximum sum of a pair with equal sum of digits. Leetcode 2342. In this problem, we are given a zero index array nums consisting of positive integers. And we can choose two indices I and j such that I is not equal to j and the sum of digits of the numbers at ith and jth index are equal. And we should return the maximum value nums I plus nums j that can be obtained over all possible indices I and j that satisfy this condition. Then in example 1, for the given nums array, sum of digits for number 18 is 1 plus 8, that is 9. Sum of digits for number 43 is 4 plus 3, that is 7. Sum of digits for 36 is 3 plus 6, that is 9. Sum of digits for 13 is 4 and 7 is 7. So we have two numbers 18 and 36 with same sum of digits, that is 9. And the sum of these numbers will be 18 plus 36, that is 54. And we have another pair of numbers 43 and 7 with same sum of digits, that is 7. And the sum of these numbers is equal to 50. And in the end, we have to return the maximum value of nums I plus nums j that can be obtained over all indices I and j. So we will be returning the maximum value here, which will be 54, and that will be our answer. Then in example 2, sum of digits for numbers in nums array are 1, 3, 10 and 5 respectively. And here we can see that there are no two numbers having the same sum of digits. Hence we cannot form the pairs. So we will return -1 in this case. Now before delving into the solution, let's look at how we can calculate the digit sum. For that, we take a number and extract the last digit of the number by taking the modulus 10. For example, if we had the number like 123 and we perform the modulus 10 on it, we will get 3. And once we have extracted this number, we add this digit to the accumulator variable. Let's call it digit sum. And then we remove the last digit from the number by performing the integer division by 10. And we repeat this process until the number becomes 0. So for 123, we will divide it by 10 and we will get 12. Then we again perform the modulo 10 operation on the number. And this time we will get the remainder as 2. So we will add it to the digit sum. And we divide this number by 10, which will give us 1. Then we again perform the modulo 10 operation on the number, which will give us 1. So we sum this number and divide this number by 10. And this time we will get 0. So sum of the digits will be equal to 3 plus 2 plus 1, that is 6. Now the function works in O of k time, where k is the number of digits in the input number. We can also write this time complexity as log 10 number, as we are continuously dividing the number by 10, which we can do logarithm of number times. And note that in this problem the numbers are positive, but if they were not, then we can take the absolute value of the numbers and run the same algorithm. Now in terms of solution, one of the naive approach can be that we examine all possible pairs in the nums array by running two nested loops, compute the digit sum of both the numbers, and if the digit sum are same, then we will calculate the pair sum and update the maximum sum accordingly. But the time complexity of this approach will be O of n square into k, where n is the number of elements in the array and k is the average number of digits in the number. And this is because we run the nested loop to iterate through all the pairs, resulting in O of n square time complexity. And then for each pair we calculate the sum of digits, which takes O of k time on average, resulting in overall time complexity of O of n square k. And now the question is, can we do better? And the answer is yes. The bottleneck of the naive approach is that we are again and again calculating the digit sums and matching the numbers. And in this problem, we know that maximum sum of a pair with equal digits will always come with numbers with the same digit group. So instead of comparing every possible pair in array, we can organize the numbers into groups based on their digit sums. And which data structure can help us here? The answer is Hashmap, because inserting the element in the Hashmap and looking up for it takes O of 1 time. So we will compute the digit sum of all the numbers and add them to the Hashmap, grouping all the numbers by digit sum, say in the list. For example, in this given array, first number we see is 18 and the digit sum is 9. So we add 9 to the map and create a new group, which will be like a list of items, and add 18 to it. Then the next number we see is 43 with digit sum 7. So we create a new group with number 43 in it. Then the next number is 36 with digit sum 9, and for 9 we already have a key in the map. So we add 36 to the group with digit sum 9. Then the next number is 13 with digit sum 4. So we will create a new group 4 with number 13 in it. Then the next number is 7 with digit sum 7. So we add it to the group 7. And the next number is 54 with digit sum 9. So we add 54 to the group 9. And now we are done with all the elements in the nums array, and we have following 3 groups. Now once we have formed these groups, we can iterate on the map and find two largest value in all the groups. So this will be like a second pass in a way. And to do that, we sort the group in the descending order and pick up two largest element from it and compute their sum, and the maximum sum among them will be our answer. So for example, for group 9, we have three elements 18, 36 and 54. So we sort them in descending order and we will get the elements like 54, 36 and 18. So we pick up the first two elements 54 and 36 because they will be the largest and sum them up. So we will get the sum as 90 and we will set it as the maximum value. Then the next group 7 has two elements 43 and 7, which will result in sum equal to 50, which is less than 90. And group 4 only has one element, so we can skip it because we can't form a pair. And throughout the iteration, the maximum sum we had was 90 and that will be our answer. Now in terms of time complexity, forming these groups will take O of n into k time, where n is the number of elements in the nums array and k is the average number of digits in the numbers. Because for each number we compute the digit sum and add it to the hash map, resulting in total cost of n into k. And then for each group, we sort that group, and suppose the group size is m, then the sorting operation will take O of m log m time, and summing up over all groups, we will get the time complexity close to O of n log n, since the total number of elements across all the groups is n, and hence our time complexity will be O of n into k plus n log n. And in terms of space complexity, it will be O of n because we are storing the group numbers, hence the maximum space usage will be O of n. Now the slight optimization that we can do is, instead of storing these elements in the list, we can store them in the max heap, because fetching the maximum element from the max heap just takes O of log n time, where n is the number of elements in the heap. And because we need just two largest elements, we can just poll it twice, and because of this our overall time complexity reduces to O of n into k plus 2 log n, which will be equal to O of n into k plus log n. But do we really need to save all the numbers in the group? And the answer is no. We just need two largest numbers. So why not just keep two numbers in the sorted list or in the max heap? Then the time complexity of sorting reduces to 2 log 2 for each group, which will be like a constant. Or if we store it in the max heap, it doesn't matter, because then we will be pulling two elements from the max heap with log 2 time complexity, again a constant. So then our overall time complexity reduces to O of n into k, but the space complexity stays O of n, because in the worst case, each element will have its own group, resulting in space complexity of O of n. And let's quickly see this in action. So we will again form the groups like we were doing earlier. So we added 18 to group 9, 43 to group 7, 36 again to group 9. Now the group size here becomes 2. Then we add the element 13 to group 4, element 7 to group 7. Now this group size is also 2. Then comes 54, which we add to group 9. But now the group size is more than 2. And in this case, what we can do is we can just sort these three elements in the ascending order. And here the elements are already in the ascending order. And remove the first element, like 18 in this case. And now we again have two maximum elements in the list. And anytime the third element comes in, we will repeat the same process again and again, which will keep the maximum size of the group to 2. And then we can again go through these groups and calculate the maximum sum among them. And now the question is, can we do it in one pass? That is, can we avoid the second loop to calculate the maximum? And the answer is yes. Now in the first loop, as soon as we have two elements in the group, we can start calculating the group sum, and maximum among them will be our answer. Now let's jump into the code part. First, let's write our helper function, sum digits, which takes in the number and return the sum of the digits of a given number. So initially our answer will be equal to 0. Then we will loop until the number becomes 0 and extract the last digit of the number by performing the modulo 10 operation and add it to the sum, and remove the last digit from the number by dividing the number by 10, and in the end return the calculated sum of digits. Now let's write our maximum sum function. Let's create a hash map to group the numbers by their digit sums. Let's also initialize our answer max to -1 to store the maximum pair sum seen so far. Now we will iterate through each number in the input array nums and calculate the digit sum using sum digits helper function and add the current number to the respective group in the map. And if a list doesn't exist for the digit sum, we will create one by using compute if absent method. Now we will retrieve the list of numbers corresponding to this digit sum and sort this list in the ascending order. If the list has more than 2 elements, then we will remove the 0th element from the list, leaving the largest 2 elements. And if the list has exactly 2 elements, we compute the pair sum and update the maximum pair sum if it is larger than the current maximum. And once we are done with all the numbers, we will return our answer. Now let's submit this code. Awesome. Now let's look at the final approach for this video. In the previous approach, for each digit sum, we were storing group of 2 numbers, which was decent in terms of time complexity. But do we really need to store the group? The answer is no. We can also solve this problem by tracking the maximum value we have seen so far for each digit sum. Let's see why. We want to find the largest sum of 2 numbers that have the same digit sum. Suppose we have a number x, which is currently the maximum for a given digit sum, say a. When we encounter more numbers with same digit sum, then there are 3 possible cases to consider. Case 1 is that this current number remains the largest for the given digit sum. In this case, eventually, we will be summing up this number plus some second largest number throughout the iteration, resulting in the maximum sum we have seen so far. Second case can be that the current number becomes the second largest element and we may find some other maximum number in the future, let it be y. Then this number x will pair up with y and again produce a maximum largest sum, and then eventually this larger number will replace x as the current maximum for that digit sum. And the third case is it is neither the largest nor the second largest. Then eventually it will be discarded since it cannot contribute to the maximum sum. For example, for digit sum 9, we had elements 18, 36 and 54. And now if we track the maximum element we have seen so far for digit sum 9, first number we see is 18. So it will be the maximum number. Then we see 36. Now 36 is more than 18. So now this becomes maximum. But we will calculate the sum of the previous maximum and the current maximum, which will give us 54. Then we see 54. Now this becomes the maximum. But we will calculate the sum of 54 and 36, which will give us 90, which is more than the previous sum we have seen so far. And suppose later we saw 9, then the maximum value will stay 54 and their sum will be 63. So it will be discarded anyways because we already have a maximum 90 here. And suppose after that we saw 45, then 54 will still say the maximum number. But when we sum them up, we will get sum as 54 plus 45, that is 99, which is more than 90. So just by tracking the maximum value, we should be able to get the sum of the maximum and second maximum element without having to explicitly create the list. So then our approach can be that we can maintain a hash map where key is a digit sum and value is the largest number we have encountered so far for that digit sum. And then for each number in the array, we will compute its digit sum and check if this digit sum exists in the map. And if it does, then we will compute the sum of the current number and the stored largest number for that digit sum and update the maximum value based on it. And once we are done with updating the maximum sum, we will update the hash map with the larger of the current number or the previously stored value for the digit sum. And in the end, we will return the maximum sum as our answer. So now let's quickly see this in action. So first number we see is 18 with digit sum 9. So we will add it to the map with maximum value 18. And because we are adding this digit sum for the first time, it doesn't form the group. So we go to the next element, that is 43, and we add it to the group 7. Then we see 36 with sum of digits as 9, and we can see that group 9 already exists in the map. That means we can form a pair. So we will sum up the current maximum value, that is 18 plus 36, which will give us 54, and set the maximum value here, which will be 36. Then we see 13, which is part of group 4. So we add it to the group. Then we see 7. The group for 7 already exists and 7 is less than 43. So we will not set the maximum but calculate the sum between them, which will be equal to 50, which is less than 54. So we will ignore it. Then we see 54 for group 9. So we will sum up 54 and 36, that is 90, which is more than the current maximum sum, and set the maximum value equal to 54. And now we are done with all the elements. So our answer will be equal to 90. And now the time complexity is still O of n into k, because for each element we calculate the digit sum that takes O of k time, and then we process the number which takes O of 1 time, resulting in overall time complexity of O of n into k. And in terms of space complexity, it will still be O of n, because in the worst case, each element will have its own group, resulting in space complexity of O of n. Now let's jump into the code part. Now let's update our code to store the max value in the map instead of group of elements. And now we can call this map digit sum to maximum value. We can keep our answer max as is. Again, we will iterate through the nums array and get the digit sum like we were doing earlier. And if the map already contains the current digit sum, that means we can form a pair. So we will compute the sum of the current number and the stored largest number with the same digit sum and update the maximum sum. And once we have updated the maximum sum, let's also update the maximum number seen so far for this digit sum. And now we can get rid of this code, and in the end we will return our answer. Now let's submit this code. Cool. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.